What up, nerds? In this video, I want to cover transitioning from Unity to Godot. Recently, the Godot community has received an influx of Unity users who are curious about the game engine. This video will remain relevant even for future versions of Godot, including the highly anticipated Godot 4.0. And this is because what I'm going to be covering are some of the core building blocks of Godot. The one thing I do want to get out of the way is that please understand that you are trying a new tool and it has some different philosophies in how things should be built. So if you embrace the tool of your choice, be it Unity if you're trying to learn that, Godot if you're trying to learn that, Unreal if you're trying to learn that, and work with the engine, it'll be a more pleasant time. One of the first things that I would like to cover is how you would go about building a game in both game engines. In Unity, you have your game scene, which is representative of your game world. Now, inside of your game scene, you have your game objects, and these game objects are built out of components. In Godot, there is no separation between the game scene and a game object. Everything is a scene. Okay, now these scenes are then built out of nodes. These nodes can be kind of seen like they are components. So I do have some example scenes already preset up to demonstrate some of this. So we'll go into the game object folder and open my player scene. So here you can see that I have 3 nodes, and they follow a parent-child hierarchical relationship, just like game objects do in Unity. So what I mean by that is the child inherits the transform of the parent. So if I move my area 2D node, you'll see that the collision shape node follows along with it, but not my sprite. Now, if I move my sprite, everything follows along with it. That is because of that parent-child hierarchical relationship. The topmost node in a scene is called the root node. Now, some of the things that you would see as additional features in Unity just comes out of the box with this scene system. Most notably, prefabs and nested prefabs. By default, out of the box, Godot supports the concept of prefabs and nested prefabs because a scene can be seen as a prefab as well, because it is a reusable game object more or less. You can then place these scenes in other scenes. So you would instance the scene in another scene. One example that I have set up here is my world scene. So you can think of this as my game world. So this would be my actual game scene. If I wanted to add in my prefab, but in Godot's terms, it's just a scene, all I would do is click on this chain up here and then add it. So I can add another one as well. Alright, so now I have 2 instances of this scene. And that is how you end up building a game inside of Godot. You build out your scenes, and then you would end up instancing these scenes in other scenes. And the next thing that I would like to cover is scripting. So in regards to scripting in the 2 engines, they are slightly different. In Unity, when you create a script, you on average extend from the mono behavior class. So what you end up doing is creating your own custom component, and then you place these scripts on game objects. So what a lot of people are used to is putting multiple scripts on a single game object. In Godot, when you are creating a script, most of the time you're extending the functionality of a particular node. So you won't have multiple scripts on a single node, but you can have multiple scripts inside of a scene. So right here I have my player scene again. All I did from previously was close my world scene. Now if I go in here, you can see that I have a script by having this icon, and open this script. You can see some syntax here. It's a built-in code editor for Godot. This is GDScript, and I would recommend you trying it out before going straight to C#, just to kind of work with the engine, because it is more tightly ingrained in the engine than C# is. I'm not saying you can't do C#, and the C# support is fairly good. It's just when you're starting out, I would encourage you to just go with GDScript. Converting to C# is very easy. So at the top, we have the extends keyword, which is how GDScript inherits from a particular class. All right. And then we also have this export keyword, so I can use this move speed variable and adjust the value inside of this inspector here. All right. Now then we have this process function, and as my note here says, this is the same thing as the update function inside of Unity. So it gets called every frame, and delta is the same thing as what delta is in Unity. So what I'm doing here is I'm getting my input vector by creating a vector 2, and then for my x component, I am getting the axis from my input singleton. Same thing with my y component. All right. So in order to set up your input actions, you go to project settings, and then it's in your input map. And as I scroll down, you can see here are the ones that I set up. To add any new, at the top in the action box, you just type in the action. You can press enter, and then it gets added to your input mapping. You press this plus button, and then you add in whatever type of key that you want. So physical key, I'll just press space and then press OK. Now if you're wondering what a physical key is, all a physical key is, it's the physical location of the key that you press, just in case some people are not using a QWERTY style keyboard. All right, so I'm going to go to empty that out, and that's how you set up your input mappings, just like you would do in Unity. Now, what I'm doing is accessing the position property, and I'm adding in my movement vector by normalizing my vector, multiplying it by my move speed, and multiplying it by delta. So when I actually run this, I can move around. Now the way I ran it, I pressed the F6 key, and that will run my current scene. Alternatively, you can go up here and press this button. Now, with scripts, remember, you cannot have more than one script on a node, but you can have scripts on multiple nodes. So to somewhat emulate the component style workflow that Unity has, I have an example over here. So in my component example, I have my root node, and then I have a health component, and I have a movement component. All right. And then I have my move speed here. I have a health thing here. And then when I run this scene, again by pressing F6, I can move around just fine. Now, if we dig into this script, what it does is it extends from my current node. I set up my variables, and then I call this onReady var inventory comp and that gets this node right here. All right. So on ready, what this keyword does is it will perform this action right here, whatever is over here. So it'll assign the variable at the start of ready. All right. Now, it's not exactly at the start. There is a slight timing difference, but for all intents and purposes, you can think of it as as if I did this. All right. Now, what the ready function is, it is the same thing as the start function in Unity. So this function right here will only get called the first time a node enters the scene tree. It is a part of the node's life cycle. All right. So in here, what I am doing, I am assigning my health component to my health node, and I am assigning my movement component to the movement component node. And I am also demonstrating the two ways that you can get a reference to a node. Now, this would be the same thing as doing a get component call. So in Unity, just for example, you would do get component and then sprite renderer, and this would be the same thing. All right, we just get the node reference. So because getting node references is a very common operation, the shorthand is right here. All right, you put the $sign and then you put the node's name, and it's the same thing as doing this. All right, there are some instances where you would prefer one over the other. All right. Now, when you are getting the reference to the node, you can look at it as a file system. All right. So if I had another node down here, let's just say a node. In order to get this, what I would have to do is that right there. I would get my inventory slash then node. Okay. So you can look at it as kind of like a file system. And let me go ahead and delete this node. And then I'm doing the same thing as in my player script from before. I'm getting my input vector. And then what I'm doing is I'm calling a move function on my movement component. So when I run this, it is the exact same. All right. Now, inside of my movement component, I have defined this function right here. We can ignore the stuff at top for the time being. So I take my direction, I go ahead and normalize it, multiply it by my move speed, and multiply it by delta. Then I get my parent. So what I do is get parent. It'll give me the parent node, and then I alter its position directly. Now in Godot, generally speaking, get parent calls are not something that you want to abuse too much. So, and what you can do is just call the owner property, and that will give you the root node of the scene. I do have a separate video covering the owner property entirely, and if you do have more questions about it, but the short answer is the owner property is the root node of a scene. All right. And this will come in handy if you have very deeply nested nodes. Now, up here, you may have noticed a new keyword called class name. By this being a class name and giving it this class name, I can now add this node to any other place, like any other scene. It's now in my add node dialog, like you see right here. All right. So as an example, in my health script, I don't have that. So if I try and add that, there is no node for it. But because I've added the custom class name, I now have this. All right. And that is how you can kind of emulate the component-based approach that Unity has. Most commonly, though, people will be doing it the way my player scene shows. They have most of their code in one or two scripts in the scene, and they just go through that methodology. Either approach is fine. One thing that I would like to mention about the get node calls, so if we go back to the component example, when you are doing like this $ health and this get node, you are traversing the scene tree from the place that this get node call is. All right. So if we look at this component example scene, the reason that I can just do movement component directly in this get node call is because this script right here is attached to this node, the component example root node. So all I need to do is search down here. If the movement component wanted, say, the inventory, what I would have to do is a get parent call, or I could just refer to the owner directly, and then I would call the get node method on there, and then I would search for the inventory. Or what I could do is just like in the, say, file system, when you're traversing that, you can do ... and that will go up one level. So now I'm on one node above, then slash, and then I can do inventory. All right. So so we're not confused, only if you were trying to traverse from a nested node. All right. So, but in this case, I don't need to do it because this script that I'm in is attached to the component example node. So I don't need to go up one level or anything like that. The next thing that I would like to cover is handling the scriptable objects in Unity. Now, scriptable objects is a fairly popular approach in designing your games in Unity, and in Godot, the way you would address that is by using custom resources. So if I go ahead and close out my scripts, and I'm doing this by hitting Control W, let's go ahead and close out these scenes. If we go down here to the scriptable object, what we have here is an example. All right. So in this script right here, I have exported this variable so I can interact with it in the interface. Now, if you notice, I'm not actually setting the variable like I've done in the past with the equal sign and then some value. And that is because I don't know what the resource is going to be. So I can tell Godot what type I want this export to be by doing this colon and then giving the class name. At this current point in time, custom resources are not supported when it comes to exporting in this manner. So I could not put in my custom resource name right here at the time of this video. It is something that is being worked on, however. So now, if we look at my custom resource, you can see here that I have class name stats, and then I have this extends resource. All right. So this is what a custom resource is. It is simply a class that extends resource. And then I have these two variables that I export. All right. Now I'm using this right here so I can create the actual resource object in the file system. So what I'll do is I'll right click, go to new resource, and then as you can see here, I have this stats class that I can now create, which I've already done so right here. So when I double click on it, you can see that I have different max health and different max speed, just like what you would do with a scriptable object. Now, going back to the script, you can see that when I press play, I should print out my max health, and down here, I am using the move speed, well, the actual max speed that I can move as my move speed. And this line here is the same thing that we've seen time and time again. All right, it's just getting the input vector. All right, so when I press play, if we look down here, we can see that I printed out my max health and I can move around using the data from that custom resource, which again is just like a scriptable object. I can add functions here, and then I can in turn call these functions on here. But resources and custom resources are some of the building blocks of Godot. You will be interacting with resources all the time in Godot. As an example, this texture right here is a resource to the sprite node. All right. So nodes operate off the data that is given to them. The next thing that I would like to cover is animation inside of Godot. Now, there are two primary ways that you will be interacting with animations in Godot. The first way is through the animation player node. The second way is through the animation tree node. Now, the animation tree relies on the animation player because that's where it gets the animations that it can use. So, looking at an example, we'll go to close that out, minimize the scriptable object folder, go into my animation folder, and open up the animation example scene. So here, as you can see, I have three nodes. I have a sprite node, I have my animation player node, and I have my animation tree node. When you click on the animation player node, this animation tab pops up from the bottom, okay? And as you can see, I already have some animations pre-set up for the purpose of this video. This reset animation is something that comes with the animation player when you create new nodes, so you can have an easy rest position. Now, if we want to add an animation, we'll go ahead and click on animation and then new, and then we'll give it a name. So let's just say rotate, for example, because I'm going to show you how you can keyframe anything. Now, with the animation tab pulled up, if you look at the inspector, you can see that we have keys on the side, and this is how you can keyframe something. So I'll go to the root node, I'll go ahead and keyframe the rotation degrees. You see that it gets added. I want to go ahead and go to 0.5, go ahead and keyframe that, and then go to 1 second, and then keyframe it back to the original position. So now when I press play, I have my animation. All right. Now you can add additional tracks here, such as calling a method directly. So what you would do, you just add this call method track. You choose which node you want it on, press OK, and then you just insert the key, and then select the method that you want to call. Now, keep in mind the animation player can animate any property that you see in this inspector. Okay. So what I'm going to do now is go ahead and just remove this animation. All right. And then we'll go ahead and just start off here. Now, in order to play these animations in code, let me go ahead and open up the script. What I'm doing here is every frame I am getting my input singleton. I am checking to see if my action was just pressed, and I'm just using any action. This wasn't selected for any particular reason. Then I'm getting a reference to the node. I'm calling the play method, and I am giving the animation that I want to play. All right, so if I press F6 and play, when I move left, that animation plays. When I hit the key to move right, that animation plays. All right. Now, typically speaking, you would want to put this in a variable. So up here, you would do like onReady var and anim player, and then we would just get the reference that way, and we can replace this. And now, instead of getting the reference to the node every single time we call play, we're caching our reference. Again, as I explained in the scripting section, this is just like getting a component reference in Unity. All right. So now to demonstrate the animation tree, which you would typically use the animation tree for more complex things, or the animation state machine. If we go ahead and select the animation tree, you can see that I have it already set up a little bit. All right, but when you create a new animation tree, this will end up being blank. So for the tree root, you can select any type of root resource. And for this case, I selected the state machine. All right. So then the anim player, you need to point to the animation player where you want to get the animations from. Okay. And these conditions right here, they get created automatically for you when, depending on what you do with the animation tree. All right, so we'll return back to this. Now, looking at the animation tree in here, in order to add a new state for the animation state machine, we'd right click and do add animation, and we'd just choose one. Now we can also do a new state machine or a blend space or whatever it is that you want. All right, so when you add this, that's how you actually create these little nodes. Now, if you want to create a transition between the states, you can come up here and select this option right here and click and drag. All right. Now, if you also hold shift and then left click, you can do the same thing. The transition already existed, so if I go here, we can do the same thing. And that's how you can create transitions. Now, I'm going to go ahead and delete this because I already have it set up. If we click on these transitions, we have some options up here. The switch mode, auto advance, advanced condition, so on and so forth. All right. So the advanced condition, if I hover my mouse over it, you can see what it does. All right. But more or less what happens is you create this, you fill this in with some kind of name, and that becomes a Boolean variable. All right. So then if we go back to the actual conditions in the animation tree root, you can see that I have the left and right, and here they are. They are my Boolean conditions. So if I want to go ahead and click on this active button, because the animation state machine is only active, well, the animation tree only works if it's active. If I go ahead and run this, you can see that it automatically plays, and that's because I told it to automatically play. All right, but if I press well, actually, I can't press anything, but if I press my move down or move up, like you see here, nothing happens because I have it commented out. But with Godot, I don't have to stop the game. I can just go here, uncomment all of this by hitting Control K, and then I'll go ahead and save that. And now, when I press the keys, it kind of hot reloads. I never had to shut down the game. All right. So I'm playing this specifically through the animation tree. So I'll go ahead and comment this out, save, and show that I'm playing it through the animation tree. All right, this is happening because I'm hitting the keys really fast. Now, the way I have it set up is by utilizing these conditions. If we look at this script right here, you'll see some new things. All right. So I have this variable left and I have this variable right. And all that's going to be representing is the the advanced conditions that I set here. Now, what you'll see here is this new keyword called set get. In Godot 3, this is how you can set up a setter or getter for your property. So anytime this property is accessed from outside of this node, this function will get called, the setter or the getter, depending on what it is that you have set up. As you can see here, I've opted to not set up a a getter method, only the setter method. So what I'm doing is anytime I am accessing this left variable and I'm setting it. So if let me go ahead and shut these down so we don't get confused. So if I go in here, you can see that I'm getting that reference, I'm accessing the property, and I'm assigning the value. All right. So because of that, it is calling these set left and set right methods. Now, in order to change these properties, you have to use this string. All right. You have to use the string. There is no property that you can actually set through it. You have to go through the string. And the way to find the property to use is if you highlight over the property, it tells you in the little tooltip. All right, so parameters / conditions / left. All right. Now, alternatively, if you didn't want to rely on just setting the values directly, which is kind of the way you do it in Unity with its state machine, you set up your variables, and then you inside of your code you can flip those variables to pretty much end up being true or false or some way. All right, but if you didn't want to do that, you can also do this right here. So you can call travel directly, and it uses A star to travel from one node to another node. If there is no connection, then it won't be able to actually do that travel. All right. So the way I have set this up is I have a script on my animation tree that kind of encapsulates all of this behavior, so anywhere else in my scene can just interact with it in an easy way. Okay. So some of the key things to remember is when you click on the animation tree, you can get the properties that you need by hovering over the actual condition. You have to use this setter like so in order to actually get it, to set it. There is an equivalent get function like that, and you can get any property. Now, these functions right here, get and set, you can use these for any property in the entirety of Godot. All right. So let's say you wanted to get the left property up here. All you would do is this, and this works on every node. Okay. Now, if you are accessing the animation tree directly, you don't need to do it this way. You could actually just, let's do animation tree. You can actually access it this way. All right. So we'll just do false for the time being, just so we don't get any parser errors. But in here, you can do the actual condition name. So I'd type in parameters condition, spelled that wrong, and then left. All right, and this line is equivalent to this line right here. Okay, so let me go ahead and just remove that. And one other thing to keep in mind with the state machine is it needs an entry point. So that's why I have the start right here. And in order to set that up with the node highlighted, you just come up here and click on this button right here. All right. So the next thing that I would like to cover would be events. Now, in Unity, uh, oftentimes you will be dealing with events, and for some instances, you may not even be aware that you're dealing with events. One of the most simple examples would be if you are trying to set up some kind of trigger box. So you have this area that you want to go to, and when you enter that area, you want some kind of event to happen, right? In Unity, it would be like a collision style event, right? So let's go ahead and explore how we can do that in Godot. Go ahead and close this stuff out. Then we'll go into the events. So in here, I have an example world scene, all right? So I have a script on my world, I have a script on my player, and then we have this other script right here. Well, this other icon that we haven't seen yet right here. It lets you know that this node right here has its signal connected to something. So if I go over here into this node doc, you can see that I have area entered right here, and then this little green icon that tells me what method it is actually associated with. Now, in order to connect that, all I do is just double click it. So if I double click that, I get this new dialog, and it asks me, where do I want to connect this signal to? All right, so signals are events. Then I can go ahead and name it if I want. And then if I hit connect, it would create that method for me. All right, so that's how I set up that signal. Now, let's go ahead and see what this signal is actually going to do when we run the game. So we can double click on the method that it's connected to. So right here, this is what it is connected to. And all I'm going to do is print this argument's name. Okay. If you look at all it is the same stuff that we've seen time and time again this far. It is just moving the character. Okay. So I'm going to go ahead and play, move, and as you can see down here, I've printed the name because if we look at the editor, this area right here collided with this area right here, more or less. All right, so they overlapped each other. So my player's area, because it is a child, when it moved over, well, let me make sure I have the right node selected. When it moved over, as soon as it's entered this area right here, it fired off that event. And that is because I've connected this event to my player script. All right. Now, you can also create your own custom events. All right. So in my world script, I've already somewhat set it up. So what I'm going to do is go ahead and uncomment all of this. All right. So this is how you can connect to an event, but in Godot, they're called signals. This is how you can connect to it in code. You get a reference to the actual node, you call this connect method, and then the first argument is going to be the signal. Also, this is the event from Unity, so you want the signal name that you are trying to connect to. Okay. The second argument is going to be the node that has the method that you want to run. So in this case, it is self. So I'm referring to the current node. All right. And then the third method is, well, the third argument is the method that you actually want to run. So in order to actually set this up to actually allow the signal to even exist, what I will do is go into my player script, and then I'll use the keyword signal, and then go ahead and create the signal. So I've now created the signal. All right. So Nope, I actually named it trigger enter, and it should be entered. So now down here, what I want to do is emit the signal, all right, and then it will populate with some of the signals that you can use. I'm going to use my custom signal, which is trigger entered, and then that's it. So now when I enter it, I get that message because my world received this signal. Again, signals are events, and then it ran in this code. You can also pass arguments if you like to. So what I would do is open it, and let's just say speed. All right, that's the argument that I'm going to pass. So when I'm emitting the signal, I'll go ahead and do a comma, and then I'll just put in 80. Or you know what? Let's just use the move speed. So save it. Now the world, this receiving signal should be expecting an argument now. So we can just do that. And now we'll go ahead and just print the speed. Go to comment this out by hitting Control K. Run it by hitting F6. And then when I move into the area, I print that argument that I have in that signal, which again, signals are events. If you want to connect to a signal in code, this is how you do it. If you want to connect a signal through the user interface, you do it under here. Now, Godot also has the idea of groups, and what you can think of groups as is kind of like a tagging system. So in Unity, you can give any number of game objects any kinds of tags that you want, and from there you can filter based on tags. You can only do things on tags, so on and so forth. So we left off with talking about groups in the last section, and I kind of want to expand a bit more on that. So like I said, groups are kind of like a tagging system from Unity. So you can add any number of nodes to any number of groups. So to do so, you would just add the group here. Let's just say player, and then all I did was hit enter after that. You can also manage the groups here and change a number of things all at once. But what we can do with that is, just as a quick example, we'll get the tree, and then what we do is get nodes and group, and then we would type in the group name, and this right here is going to return a list of nodes that are in this group, so you can really filter for only the nodes that you care about using this kind of tagging system. Now, that's really all I wanted to talk about with groups. They are useful. You can just look at them as kind of like a tagging system. One of the last things I want to talk about is inheritance. Godot supports inheritance just straight out of the box, and it's through script inheritance or even scene inheritance. Now, if you look down here in my inheritance folder, I don't have anything created because I want to show you how you would do this. So what we can do, we'd go up here in the top left and do scene and then new inherited scene. All right. And we can just choose the player character, for example. All right. Now, the player character is a scene that I haven't shown before, but this would be kind of how a basic character would look. You have a kinematic body, 2D, as your root node. You'd have the sprite node to represent the visuals of your sprite. And then you would have your collision your collision shape object. All right, so you define the bounds of your collision. Now, what I can do is, let's say I want to add additional functionality to this scene. All right, let's just say I want to add this movement component. All right. So if I save this, let me go ahead and save it in the inheritance scene. If I save this, and then up here, you see that I have these nodes right here, and then my extra one. So when I go into my game object and go into my player scene, you can see I don't have that anymore. All right. Now, let's look at what happens here. My move speed is set to 80, or set to 100, and I'm on my inherited scene. All right. So now, when I close that out and then change this to 50, when I save that, let's go ahead and close that. We'll go to our inherited scene. This is now set to 50. So it works just the same way as your typical inheritance works. You can create a base, say, character scene, and then you can create child scenes, so inherited scenes, and just change the sprite texture, for example, and you can rapidly create whole new characters. All right. Now, I'm going to go ahead and delete this because the movement component really wouldn't work in this case, because if we look at the script for my player character, it already has movement built into it. So when I do this extends kinematic body 2D, what I am doing is inheriting kinematic body 2D. I can also inherit from custom classes. You can also inherit from script paths directly. So if I wanted to inherit from this script right here, I can drag and drop it and then remove this like so. And now I am inheriting from my player script. And as you can see, it recognizes that and says, hey, this is already defined in that script. So that is how you can take advantage of inheritance. So to finish all of this off with, let's talk about the physics side of Godot. In Godot, you have a few different ways to actually do physical interactions, be it with a kinematic body, a static body, or a rigid body. In 4.0, the API is going to change a little bit, so I would recommend reading the documentation when 4.0 is ready to be actually used. Now, right here I have a kinematic body. It is most commonly used when you want to have more control over your actual characters and physics operations and all that. So, just real quick, we have the physics process, which is identical to fixed update in Unity. So, same thing here. I'm getting my input vector. I am then multiplying it after normalizing it, multiplying it by my move speed, and then in here I'm calling this specialized function that exists in the kinematic body in order to move my character. So when I go ahead and try and move them around, it still works. And the reason I am not using delta is because, like this note says, move and slide, this method specifically, already uses it internally. And you can find this kind of stuff out by reading the built-in documentation for Godot. If you control click on a method, it will take you to that method's documentation that's built into the engine. All right. And you can go ahead and read all of this. All right. You can see that there's quite a number of things that the kinematic body actually has. Alternatively, you can click on the search help up here, and you can see that you can just type in any method, and then you can also type in a class. So let's say rigid body, and you have whatever document you want to take a look at. All right. When it comes to collisions, what you will see if you go to these collision objects, in the kinematic body, you do have this safe margin, which you can read the documentation for what it actually does. A lot of times, I'll be honest, I haven't had to adjust this, but you have collision layers and collision masks. All right, and simply put, the layer is the collision level that you actually live on, or it's the collision room that you're in. And mask is going to be the collision rooms or the collision levels that you're actually looking for collisions on. So if I don't have this mask on, this object is not looking for any collisions for pretty much anything because nothing is selected. All right. And that's just a quick summary on how the collision stuff actually works. I would recommend, obviously, just trying things out, just exploring the API and seeing what you can actually do with the physics side of things. So we've covered a lot of information in this video, and that is why I've broken it up into sections. This way you can go back and watch the section that is pertinent to you. Just as a quick recap, we've covered how you build your games in Godot. You do it through scenes and nodes, and you can place these scenes inside of other scenes. We've also covered the animation system as well as the events system. And all the event system is signals. We've covered how you can approach Godot with a component-based workflow, as well as how scene inheritance works. We've also covered how custom resources are the equivalent to Unity's scriptable object. We've also covered some of the lifecycle methods of Godot, being that ready is the equivalent to start inside of Unity, process is equivalent to update inside of Unity, and physics process is equivalent to Unity's fixed update. We've also covered some of the syntax of GDScript, as well as how to expose things to the inspector. We've also covered how you can set up your input mapping, as well as how to get the values from your input mapping. We've also covered how groups are like a tagging system, as well as how the collision layers and masks work. Now, I didn't go too in depth with the physics side of Godot because it largely follows the same principles in that, with like the rigid body, you don't want to alter the state directly. You want to rely on, say, things like add force or add impulse and things like that. We did cover how you can look up the API with the built-in docs inside of Godot, though, and I would highly encourage you to actually explore it. Now, there's a whole lot of things that I still did not cover, as this is just supposed to be an overview of Godot. So some things that I didn't cover would be, say, building tools inside of Godot, which is a fairly pleasant experience. How you can build out UI in Godot. I didn't cover like all the nodes that you have access to, which I encourage you to actually look at. And I also didn't cover singletons inside of Godot. They're really easy, but they're also super useful. Just as a quick touch up, a singleton in Godot is called an auto load. If you go up here in project, in the project settings, you see this section right here called auto load. When you have a script or a scene, because either one can be an auto load, all you would do is open here. We can just choose any single one. Let's just choose health. Then when we add it, this is a global variable. So in any script, I would just type in health and then access it that way. So that's how the auto load is, just as a quick recap. For more information, I encourage you to read the docs. There is a whole lot of things that you can do with Godot, such as building a tool that kind of imitates Control Rig from Unreal. I would encourage you to use GDScript for at least 1 or 2 small projects so you can get a better understanding of the engine itself. GDScript was built with Godot in mind. It was designed specifically for Godot. If you end up wanting to transfer over to C Sharp, I can promise you that it is a very easy transition to make. I've done it a couple times for various contracts. If you have any questions, please ask in the comments below. See you, nerds.